Right, so here we've got question 7 from the CWC test, and we're asked to find the binomial series expansion of the root of 4 minus 9x, and we only need to do it in powers of x up to the x squared term. So we know we've got the binomial expansion formulae in our formula book. For this one, because the root of 4 minus 9x is equivalent to a power of a half, we can't use the a plus b to the power n formula. We have to use this form, which is 1 plus x to the power of n. And we can use this when we've got non-integer powers or non-positive integer powers. So we need to write this expression here in terms of like this one. So we need a 1 as the first term in the brackets. So the first thing to do is rewrite this as a power of a half. We can see we've got 4 inside, we want a 1, so we've got to take a factor of 4 outside the bracket, remembering that the 4 is raised to the power of a half as well. So if I take the 4 out, I need to write it as 4 to the power of a half, and then I can divide the bracket by 4, and I get 1 minus 9 over 4x, all to the power of a half. And I can simplify the 4 to the power of a half, that's just the square root of 4, so I get this expression here. So this is now in this form, obviously with a 2 out the front, so I need to make sure I keep that 2. So at this stage I can now just substitute my x, which is the whole of this bit, so negative 9 over 4x. I can substitute that into this formula wherever there's an x, and my n is a half, so again I can substitute a half in wherever there's an n. So just pause the video, take a moment to check that you understand where this expression here comes from. So I've kept the 2 as I suggested we needed to, and then I've just substituted in negative 9 over 4 for the x's and a half for the n's. Okay. By taking the factor of 4 out and writing it as 4 to the half, or 2, that gives you 1 mark, and then if you have tried to substitute into this formula, you should get a method mark and an accuracy mark for this expression here. Please write it out in full, just substitute in before you try and simplify it, because you'll always make mistakes if you try and do it all in one go. And even simplifying, I tend to do in 2 goes, because it's quite a complex expression. So this first part, that's fairly easy to simplify, and I get minus 9/8 x. This bit comes out to give negative 1/8, and then when I square this, I have to make sure I square the coefficient to get 81 over 16, as well as squaring the x. And then I can simplify this third term further to give 2 minus 9/4 x, or sorry, yes, I've also multiplied through by 2. This comes out to be 81 over 64 x squared, negative that. Alright, and you'll get 2 more accuracy marks if you correctly get to that expression there. There is a way of checking these binomial expansions, because if we substitute some value into this form of the expression and also substitute it into this approximation, then the answers should be similar. Not necessarily, or not the same, because this is only an approximation. We've only gone up to the x squared term, but they should be similar. So I've just chosen a value of x, substituted it into this expression, which gave me 1.73 and so on, and then substituted the same value of x into this approximation, which came out to be 1.73, etc. as well. So it looks like that could well be correct. For part B, we were asked to state the range of values of x for which the expansion is valid, and in the formula book it states that this formula holds when the modulus of x is less than 1? Well, in our expression, we haven't just got x, we've got negative 9 over 4x. So what we can say is that the modulus of that is less than 1. So I can write that modulus of 9 over 4x, well, I could have put a negative in there, doesn't make any difference because it's modulus, is less than 1, and then I can solve for x, so multiply by 4, divide by 9, and I get the modulus of x is less than 4/9, and that will get you a mark. The last part was definitely not easy, and so I'm going to show you what a lot of students tried and explain why it doesn't work. So a lot of people quite rightly thought, well, this is the expression I've got and I'm trying to find an approximation for this, so I want my 4 minus 9x to equal 310, and if you solve that you end up with x equals negative 34. But we know that this approximation only works if the modulus of x is less than 4/9. Well, the modulus of negative 34 is 34. It's definitely not less than 4/9. So unfortunately, that won't work, that approach there. So we need to use a different value of x that's going to help us approximate this, and the value of x has got to be very small. It's got to be 0 point something basically, or negative 0 point something. So you might be able to see a relationship here. 4 minus 9 times something very small, well, that could be used to get 3.1. Certainly can't be used to get 310, but can be used to get 3.1. And if you look at what we're trying to find, the root of 310, you might spot that that is equivalent to root 100 times root 3.1. So that we can use our approximation to find, because we can say that this is equal to 10 lots of root 3.1, so we want 10 root 4 minus 9x to equal 10 root 3.1, and to do that we can use an x value of 0.1, and that, the modulus of that, is definitely less than 4/9, so this should work. Okay, so this is the x value I'm going to use, and it says to use our expansion, so I'm going to substitute this value of x into the expansion we got in part A. So I keep my 10 out the front, and then I've just substituted in my x, or my 0.1 for x. And this will only be an approximation, so I've said about equal to. I can then just put all of this in my calculator. I've done it in parts, and it eventually comes out to be 17.623. There is a way to check these, because in fact it's quite easy to check, because obviously this is an approximation of this, so you can just put this in your calculator, which comes out to be 17.607, and check that it's relatively similar, which these are fairly similar, so that would suggest we're on the right path. We've got that right. And that's it for that video.